Hello. In this video, we're going to look at question 4b on exam 3 review. So we have f of x equals x squared e to the x minus 5, and we want to find any relative extrema. We need to go ahead and find the derivative here, and the derivative we'll have to use the product rule. So it's going to be the first one, x squared, times the derivative of the second. The derivative of e to the x is e to the x times the derivative of the exponent, but that's just 1, so I don't need to deal with it. And then plus the second one, which is e to the x, times the derivative of the first. The derivative of x squared is 2x. Good. So that's the derivative of x squared e to the x, and then the minus 5 goes to 0, so I don't need to write it. Notice that there is a common factor of e to the x here. So if I factor out e to the x, what's left over is x squared plus 2x. And technically, there's a common factor of x. So I can do x e to the x, which is x plus 2 left over in parentheses. And this is a good way of looking at the derivative here. And again, because the domain is negative infinity to infinity, then the relative extrema will occur the critical numbers are anywhere where this is equal to 0. So it means that x is equal to 0, e to the x is equal to 0, and x plus 2 is equal to 0. The first one is already solved. We love that. E to the x equals 0. Well, any exponential is always positive, which means it's never equal to 0. So there's no solution there. And x plus 2 equals 0 gives me x equals negative 2. And there we go. 0 and negative 2 are our critical numbers. So looking at our number line here, we have negative 2 and 0 as our critical numbers, but we need test points now. Well, so let's say maybe negative 3, negative 1, and 1. And be sure to plug those into the derivative. Now, we can do these in our head, honestly, but just so you can see, again, on the calculator, on y1, I'm just going to go ahead and top in the derivative here, which was x e to the x parentheses x plus 2. So if I go to the table, my test points are negative 3, negative 1, and 1. So notice that negative 3 is positive, negative 1 is negative, and 1 is positive. So it's positive, negative, positive. Good. So what that's telling me, finding the relative extrema, negative 2 is a relative maximum. 0 is where you have a relative minimum. So to figure those out, though, we need to actually plug those into the function, negative 2 and 0, into the function. Now, the original function, not the derivative. So just to see what those would be, let's go to the calculator. On y1, I'm going to go to top in the original function, which is x squared e to the x minus 5 there. And then for our points, they were negative 2 and 0. So at negative 2, it was negative 4.459. And at 0, it was negative 5. Good deal. So notice that negative 2 is a relative maximum. 0 is a relative minimum. So there is a relative maximum of negative 4.459 at x equals negative 2. Now, if it's the coordinate, just say it's a relative maximum at negative 2 comma negative 4.459. That works as well. And then if you have a relative minimum, it is a relative minimum of negative 5, and it occurs at x equals 0. And there we go. That is example 4. Yeah, 4b. All right. Have fun.